before we start, I would like to thank once again the sponsors of this workshop, the Ethereum Foundation and the Tezos Foundation. Thank you very much. So, lamentably, I'm old enough to be able to say to my kids things like, you know, when I grew up, phones had the cords attached to them. All phones had cords attached to them. Or, you know, when I grew up, kids had respect for their elders. But now I digress. So another thing that I guess all of you sitting here, even the younger ones, are old enough to tell your kids one day is that, you know, back in the day, all of our economy and financial system worked in this trusted party model with banks and financial institutions that basically you trusted. And when your kids would ask you, hey, but who really has authority to answer, yeah, Daddy, you can, you know, address that as well. But Mommy, like, how can you trust those big trusted parties? What about corruption or incentives and so on? So the answer would be, well, there was this cabal of experts, you know, appointed by the state or anointed by various ceremonies, and they were auditors and accountants and regulators that were appointed and to whom accountability was delegated, and they were sent and they inspected things like balance sheets and, you know, systems, and they came off signing and saying, okay, everything's okay. But your kids will obviously know that that's not how the system works these days. Today, we are on this new model, you know, that was ushered in first by Bitcoin and then by other cryptocurrencies, in which everyone is invited to verify the integrity of the system. So this is the notion of inclusive accountability. If you have a laptop and internet connection, you are invited to join the system and verify each and every aspect of the system, as is captured by this phrase, verify, don't trust. But I mean, your kids will already not ask this because we'll be way past this thing, but you may ask today, if everyone verifies and sees every aspect of the system, then what about privacy? And what about scalability, right? Privacy gets compromised if everyone sees each and every transaction. And scalability is also an issue, because if I want my laptop to also be running other things other than just you know, just verifying a blockchain, then it's going to be hard to scale the system up and up. So these are big problems, privacy and scalability, and I mean, we believe that by the time your kids will be all grown up, they'll also know that the way these things are solved are by these systems that have the properties of being zero knowledge, which is how privacy is preserved, in which a proof does not show and reveal anything about the inputs that went into it. And the S in the word Stark stands for scalability, which in particular means that proofs are succinct and exponentially smaller than the amount of computation being asserted, and thereby you can also address scalability. So this is sort of a broad overview, and this is also a sort of a more abridged version of things that we have been saying in the past. And now I want to get to the new stuff, which is also what this sessions today is about. So StarkWare sessions in general, and also the things I'll be talking about in my talk today, broadly address, I think, two questions. The first question is, what is the role of ZK Starks in this larger ecosystems of zero knowledge proof systems? That's question number one. And this is, roughly speaking, this will be more addressed in the academic track that we'll have today. The second question that this talk and also the sessions today deals with is, what is the role of StarkWare as a company inside the larger blockchain ecosystem? So I want to start by addressing the very first question. Wait a second. Sorry, I don't know what's going on here. Okay. Yeah, okay, good. So, I think now we're fine. Okay, so I want to start with the very first question, which is what is the role of ZK Stark inside the larger ZKP ecosystem? So I want to ask, is there any marine biologist in the audience? Very good. So no one's going to call me out for the errors I'm going to make. So there's this thing called the Cambrian explosion, which happened 541 million years ago, give or take a few minutes. And during that thing, scientifically speaking, before that explosion, there was, the Earth was covered by a whole lot of slime and goo, like all these microbes floating around. And then, boom, all of a sudden, snails and whatnot and various critters started appearing. So far, this is as much as we'll go into biology. But we do live today in this Cambrian explosion of ZKP systems. So what started 30 years ago or so in the mid-'80s with very theoretical notions that were mostly the playground of theoreticians and cryptographers, over the past few years started, Cambrian exploding into a variety of systems. So first there were deployments of things like Snarks and Zcash, and by now we have things like, Sonic, Bulletproofs, Starks, Ligero, Aurora, Zkaboo, more recently Plonk, Halo, and frankly, I don't type fast enough to, be able to record all of the systems. For instance, in the slides, we don't have, we didn't have time to add also Dark and Supersonic, and if I don't speak fast enough, there'll be a few more by the time this talk is done. So there's a wide variety of ZKP systems, which is, of course, really, really great. And what I want to discuss a little bit is why we are focusing, or why we believe in a very particular version of these systems. And the answer for this has to do with future-proofing the financial highway. So all of us in this room, I think, believe that blockchains have the potential for being the infrastructure on which someday trillions of dollars of value and commerce are going to be transitioning and transiting day by day, right? So when you're building this super highway on which all of the world's economy is going to rest, hopefully in a few years, you really want to use the materials that are going to be future-proof and sturdy. You don't want to be building one of those bridges and then be standing there and saying, oops, right? Okay. So this is captured by things like the Lindy effect that says the future life expectancy of some non-perishable things, like a technology or an idea, is proportional to their current age. And some of the systems, the one that are more on the left, famously they are post-quantum secure, or plausibly so, post-quantum secure. And you definitely want your systems to be robust enough so that even if nation states are progressing along their technology and science, you know that your systems are still have the capability to deliver what they promise, things like privacy and scalability. But the analog of the Lindy effect inside theoretical computer science and cryptography is captured by this notion of reductions and cryptographic assumptions, right? So until we resolve such questions as the P versus NP problem, which is a famous open problem, we really, when we build systems in cryptography, we need to base them on some assumptions and reduce our systems to those assumptions, saying something like, if my system is broken, then I can prove to you that you can also break some other thing that's been around for a while and people believe is pretty robust. And of course, the longer this thing that is tied to your system has been around and the more value is based on it, probably it's a safer thing to use and it's more future-proof. So if we look at these different systems, and again, this is not the full world of them, you can sort of partition them according to the cryptographic assumptions that underlie them. And let's see now. So at the very right, you're very right here, we have systems that are built on the assumption of knowledge of exponent in elliptic curve groups. And these assumptions are pretty recent. They started around the early aughts. And some of the assumptions on which these systems are built, things like the generic group model, are even more recent. Okay. If we go to the middle, we see things that are based on elliptic curves, discrete log, the hardness of the discrete log in elliptic curves, and also on pairings. And there are a bunch of assumptions there that start from the 80s and go up to the aughts. And if you go to the rightmost part, sorry, the leftmost part, the biggest tree, is the one that has the deepest and longest roots based on collision-resistant hash that already appeared in this very early work by Diffie and Hellman in 1976. And basically, these systems are such that if you can break them in a way that is unrevocable and unfixable, it means you essentially have no collision-resistant hashes in the world. In particular, you don't have discrete log problem to use, because if the discrete log problem is indeed hard, you do have hash functions like Peterson and others. And in particular, you don't have things like knowledge of exponents. So you could also think of it as, I mean, if this tree falls, this tree falls. And if that tree falls, these two trees fall. So in terms of future proofness, you'd rather have your infrastructure use things that have very deep roots. Now, another way to look at it is how much economic value is already built on such foundations, because you're probably safer, according to the Lindy effect and this notion of reductions, if you use things that has more stuff attached to them and more eyes have been looking at them. So if you look at knowledge of exponent assumptions, the economy that uses it probably pretty much captures today Zcash, which is around $500 million or so. So if you look at things like elliptic curves and pairings, there's a little bit more, various forms of SSL key exchange and identity-based crypto, probably in the billions of dollars of value. If you look at what is built on the security of collision-resistant hashes, you'll pretty much get all of e-commerce and SSH and password authentication, and almost all of the world of security relies in some form or another on the existence of collision-resistant hashes, and that's probably in the trillions of dollars. Okay, so summarizing, we think that in terms of future proofness, which is really important when you build infrastructures, you want to use systems that rely on minimal cryptographic assumptions. Now, one might think that because these systems have the oldest assumptions, they might be the least efficient, but it's actually exactly the opposite way around. So the Stark systems that we are building are actually fastest in class. So this is related to some Stark figure, so I'm told. Okay. So Stark, too fast, too scalable. That's another pun on something. Okay. The biggest disadvantage that is discussed about the systems that we're building is that they have large proofs. Indeed, their proofs are roughly 1 order of magnitude larger than things like bulletproofs, supersonic, maybe Planck and Halo. I mean, the numbers there aren't really out yet. They are 2 orders of magnitudes larger than things like the snarks used by Zcash, but everything else is better about them. They are the easiest to scale up, and we'll discuss this a lot more. There's no trusted setup. It's very easy to scale them up to very large sizes. They do have the fastest verification time among all systems, right? So even though the proofs are slightly larger, the amount of processing the verifier does with these proofs is actually smaller than in other systems. And it has the fastest prover, which is really important when you try to scale things up. It is at least 1 order of magnitude faster than the next in class, and I don't think this will change anytime soon because of the lean cryptographic assumptions and the efficiency of this system. So when you look at scalability, here's a plot that we already showed in the past. This is our system on Ethereum, which basically takes a whole bunch of trades and settles them using a Stark proof. And you can look at the amortized gas cost as it goes down with the increase in batch size. So we already reached batches of 8,192 transactions certified by a single Stark proof, which gives you an amortized gas cost of 800 gas per transaction. This is compared with the current gas prices of roughly 100 to 200,000 gas per per trades. I want to point out that this is with no precompiles, no special subsidies given to Stark proofs, and this is also pre-EIP 2028 numbers. This is what we just deployed in our alpha system. Now, what we haven't announced till now, but I'd like to share with you, is that we can already generate proofs that cover the settlement of 32,000 transactions, and the proof fits inside a single Ethereum block. So for the price of one block of less than 8 million gas, you can cover 32,000 transactions. That's more than 2,000 trades per second. And the amortized gas cost is around 200 gas per trade. And again, this is not some theoretical result that maybe we could someday do. This is things that are actually working now. And again, with no, thanks. And again, this is with no special subsidies, no Ethereum pre-compiles, and even pre-EAP 2028. Good. So to summarize the answer for the first question, what is the place of the kind of technologies we are exploring within the larger ZKP ecosystem? It is the fast and scalable, but most importantly, future-proof technology that we believe should be one of the main contenders to be used when you build infrastructure for trillions of dollars. Now I want to talk a little bit about StarkWare as a company and its role inside the larger blockchain ecosystem, because people often ask, in various forums, like, what exactly is StarkWare? Famously, you don't have a coin, so, what are you doing in blockchains? So, okay. Now, the first and simple answer is that we are a for-profit company, and we have our first line of products. This line of products offers Prover as a service, right? Or PaaS, right? P-A-A-S. Prover as a service. And we're going to deploy it as a layer 2 solution on Ethereum. It could be deployed on any other blockchain that has layer 2 capabilities and significant volume that needs to scale up. So the concept is a very simple one. We put the verifier on chain, but we keep the prover closed sourced, and it runs on some big machines that we operate and offer it as a service. Okay? And along this line, we have already demonstrated a few months ago the StarkDex Alpha that showed a rate of 10 trades per second, consuming only 15% of Ethereum's capacity, running for a very long time, using a live feed from Binance, and allowing self-custodial trading at scale on ERC20 tokens. This was our alpha system. It was joined with 0x. What we're going to do next is by Q1 2020, we're going to deploy Stark Exchange for scalability, and we're going to be bringing self-custodial trading to centralized exchanges. We're already working with multiple exchanges and integrating with them, so we're in advanced stages of doing this. One of these is famously Coinbase, where Brian Armstrong, their CEO, already announced this a few months ago that they are working with us. They are not the only ones working with us currently. Later in 2020, the directions we're currently exploring, we're not yet fully committed to any one of them. We'll see where our business takes us. But first of all, we're going to significantly try and extend the capabilities of Stark Exchange. And if you want to hear more about this, then come to Avihu Levi, our head of products, talk later in the application track, and you'll hear a lot more about Stark Exchange. We're also going to try and deploy Stark Pay, which offers the similar speed of settlement to that of Lightning, with the similar low gas costs, but in a way that is much more capital efficient. If you're following what's happening with Lightning, there are all these capital requirements that go away with Stark Pay. So we want to deploy that as well. And we're contemplating other things like VDF as a layer 2 solution. And these are some of the things that we're thinking about, but we are not yet committed to any one of them. So let's take one step back and look at the larger ecosystem and ask, where does StarkWare see itself fitting inside this world? So let's digress a bit. Tomorrow there's elections here in Israel, and some political theory. On the left we have the left, on the right we have the right, and we could probably do some sort of poll where people sit all the way between left and right, but it's well known that as you move from left to right, the role of government is supposed to be shrinking. It also is similarly known as that as you shrink the role of government, you're supposed to increase the role of the private sector, right? If the government is not the one that builds and maintains infrastructure, someone has to do it. And typically this is done by, a lot of it is done by the private sector. So I want to say that we proudly sit inside the private sector, and whatever corner of this map you sit in, unless you're at the very, very the extreme-most left side, that like extreme communism that doesn't want to see any kind of private sector, and I'm guessing like most of the world is somewhere in the middle, or maybe, I don't know, leaning right or something. You must have a private sector, and that's where we proudly want to sit. Now, there is this challenge that is left to the governance of blockchains, which is how to facilitate and foster a vibrant economy of private sector occupants. Because if you look around, when you talk about building infrastructure, I mean, when we at StarkWare, we have 30 employees and we're growing, we got good funding, we're very happy with our progress. But if we look like left and right and ask who else is building infrastructure, has the potential of building infrastructure, then we'd like to see more big teams that have multiple people and that are working on very basic technology and sort of know that they can pay the bills not just now but for a few years ahead. And I think this is a challenge that is left to the the leaders of decentralized blockchains to address, and there's still room for improvement from the point of view of the private sector of blockchains. And there'll be a panel discussing layer one infrastructure building later on with a lot of the leaders of these communities, Vitalik and Zaki and Arthur and others, and it would be interesting to hear their take on how to foster and facilitate these things. Now, where do we stand StarkWare with respect to developers? So our belief, and this is sort of a premise, is that Stark as a technology is this sort of basic science and technology, and it inevitably must become ubiquitous because you can't stop science and technology and you can't put any moats or walls around it. And we're very happy with that happening, and we're hosting today several people who will talk about separate deployments of, so Bobbin will talk about GenStark, and we have others talking about other ZKP systems, and we're of course very happy that this thing is happening. So that's our belief about the science and technology. Our interest as a business is in seeing a thriving ecosystem of ZK Stark developers, and the fact that, for instance, the Matter released very nice work on polynomial commitments that uses DeepFry, and I understand that there are other works, including some that will be presented today, that use some of the techniques from the world of ZK Starks is, of course, a great blessing, and it is in our interest to have many players in this world. And our actions are that we are doing things to, of course, help this happen and enable it. So we're leading some research on Stark-friendly hashes. We'll be discussing this later in the academic track, our progress on this. We have published scientific works like DeepFry that is already being used by others. There's more scientific work in the pipeline that will publish it over the next few months, and we're very excited about it. We are educating. Has anyone here attended Stark 101 yesterday? Okay, so, okay. I think, I hope that you enjoyed it and you saw that, we're eager to share this knowledge with others. We're going to dev meetups, blogs and papers. So we want people to use it because it's in our interest. In terms of developer tools, we've already committed to releasing code for the secure Stark-friendly hash functions. This will be done by summer of 2020. And we will be releasing at some point a Stark toolchain for programmers that don't necessarily need to know all the intricacies of Stark, but can work with it sort of more as a black box. This will happen sometime probably in late 2020 or in 2021. We're starting to think about this. But we want a vibrant community of others to be working with our technology. So summing up the answer to this question, what is the role of StarkWare within the larger blockchain ecosystem? We are a proud for-profit company. We want to be a member of the larger Stark and ZKP developer ecosystem. We would like to see more support and an easier thriving ecosystem that will be basically fostered by the governance mechanism of blockchains. We are content with our work right now, but we think that others would benefit if there's a little bit more of a incentivation and mechanisms that offer some long-term prospects for developers of infrastructure. And we want to educate and spawn a system of developers that will work with the technology that we like most. So going back, so today we're starting this whole day of talks, and roughly speaking, the academic track deals with question number 1: how do Starks fit in this larger ecosystem of ZKP and cryptography? And we have some fantastic talks about progress and other systems and related concepts. We have a fascinating application track that deals with the second question of where does StarkWare fit within the larger blockchain economy. And with this, I would like to thank you and say that I hope that you enjoy our sessions today.
If you have any questions for Ellie, a quick Q&A. There's microphones here and there. Otherwise, we will be separating into halls now. So hall 2 will start in probably 5 minutes, okay, the academic track.
I think there's a question there. Wait, we
Hold
want
on.
to record it.
I'll give you the mic.
Hi, Ellie. Thanks for the inspiring talk. Can you maybe state or kind of point to an industrial private infrastructure provider that you think is kind of an inspiration to you? So what would
what in outside of blockchain world?
As you're building StarkWare in the past 100 or so years, what's kind of a good example of a private infrastructure builder?
A private
infrastructure builder.
Not in blockchain world.
Not in blockchain. The world
well, you
of
have
things.
you have in the internet world you have Cisco and Akamai and I mean, and a zillion companies that build the infrastructure for the hardware and for the communication and for content relay. That's one example in that world. In physical infrastructures, you have a whole bunch of models and mechanisms for folks building infrastructure, highways, and then operating them. Things like the BOT model. I mean, in physical or licensing, like the operation of highways or railroads and so on and so forth. I think there's an abundance of examples of how government, when it sort of scales back and says, I don't want to deal with this infrastructure, sort of gives it, or the way the spectrum, the electromagnetic spectrum is handled in various modern countries. That's like cellular networks and so on. Yeah.
Thank you.
More questions? Okay, so those of you who are would like to go to the